Good afternoon, students. I'm still not feeling well, so I'm going to do this one from home again. This is your video lesson for mass and mole calculations 1, 2, and 3. And this is really all about what we've been doing here. We're going to use some dimensional analysis to move our way around mass, moles, volume, particles. So you might be given a mass and you're going to try to find the moles, or maybe you're given the moles and you're trying to find the volume. Or maybe a two-step problem, you're given the mass and you're trying to find how many particles, but of course you have to go through moles first. Or maybe you're given how many particles and you're trying to find the volume. So you have to change particles to moles and moles to volume, a two-step problem. So we're going to be using this. You'll see it on the board again. We're going to be using this to solve these problems. So as we get started here, a few equivalencies up here that you'll want to be aware of as you're solving these problems. They will help you. And of course, a lot of them are right here. When we're reading here, this first one, calculate the mass of 1.58 moles of CH4. The molar mass says CH4 is 16 grams per mole. So that's the equivalency statement. And here are the conversion factors. We can write it 16 over 1 or 1 over 16. Which one are we going to use here? Well, we're given 1.58 moles, and we're trying to determine the number of grams of CH4. That's the same as from. We're starting from what's been given, 1.58, and we're trying to get 2 grams. And you remember from yesterday's lesson that the 2 always goes on the top. Where you're going to and where you're coming from always goes on the bottom. So we have to put moles on the bottom. And we have to put grams on top. And so that's going to be our 16 grams over 1 mole. So by knowing where we're starting and where we're going, we know which of these two conversion factors to use. In this case, we're using the 16 over 1 because we're trying to get 2 grams coming from moles. Okay, now we look at the next problem. What volume will 7.29 moles of CO2 occupy at STP? Well, we can see, let's see, on this side, there's an equivalency statement. And of course, we can see it up on the board. Moles to volume, 1 mole is 22.4 liters. Okay, so we're going to use our equivalency statement, 22.4 liters per 1 mole, not 1 mole per 22.4 liters. We're going to use this one because we want to change moles into liters. 22.4 for every 1 mole. And that gives us the answer, 163.3 liters. That makes sense. Yeah, 7 by about 22 is okay. All right, now let's do the next one. How many molecules are there in 0.00583 mole sample of H2O? So we're starting with moles, and we're trying to get to how many molecules. We're going to multiply by molecules over moles this time. And the main reason I'm showing you this one is to show you how to type this in your calculator. There's this type of calculator that I have in the classroom. And here's how you do this. Make sure this is on the screen. You're going to do 0.00583 times, and then 6.02 exponent, and that gives you a place to type the 23, and you hit equals, and there's your answer. Okay, so 3.5 times 10 to the 21. 3.5 times 10 to the 21. Oops, 21. Okay, now I want to show you how to do this on one of these calculators. So I got to turn this on. My batteries are low. Yes. Okay, and so I'm going to type in 0.00583. And now I'm going to type in a parenthesis. So I'm always going to, this calculator is very powerful, but it requires a few extra pushes of buttons when using scientific notation. So I'm going to multiply now times, and I'm going to put this all in parentheses so you can't forget the parentheses. So 6.02 times 10, and then I'm going to use this little key called the caret key, and that gives me my exponent 23, and then I close a parenthesis and hit enter. And I get the same answer now. 3.5 times 10 to the 21st. So the E there means times 10 to the 21. Okay? So I think I might have been a little off the screen. Again, you type in the first number, 0.00583, type in parentheses, 6.02 times 10, the caret key, 23, close parenthesis, and you're there. Okay, and now on the back side, just one problem I'm going to do on the back side, two problems I'm going to do on the back side. I'm going to start with this one here. So notice on the back side, a little bit of scaffolding has been taken away. And so you can fill that in if you want. So in fact, I do want you to fill it in. I do want you to show all your work when you're doing these things. So here, how many molecules are in 0.25 gram sample of H2O? And we're given the molar mass. So once again, we're probably going to be using one of those two conversion factors. We're going to go from grams, and we want to know how many molecules. That's where we're going. So there we are with our grams. And since we want to find molecules, we want to go 2 molecules, we're going to multiply by, actually, I can't go from grams right to molecules. This is a 2-step problem. That's one of the reasons I'm showing you this. We're trying to go from grams to particles, so we have to change to moles first. All right, so we have to go from grams to moles, then to molecules. So now I'm going to use, let's see, I want to change this to moles. And so then I use moles over grams to cancel the grams. 1 mole is 18 grams for water. And now we're going to multiply by 6.02 times 10 to the 23rd molecules per 1 mole. And if we wanted to change this to atoms, if we wanted to take it one step further, we just multiply this answer, the answer we get here, by 18. And we would have our final answer for number of atoms. But here you're just going to multiply 0.250 divided by 18 times, don't forget to use parentheses, 6.02 times 10 to the 23rd, and close your parentheses and hit enter. And unless you're using this calculator. So I'm going to show you one more here. What volume will 3.01 times 10 to 22 times 10 to the 22nd molecules of CH4 occupy at STP? So where are we starting from? We're starting from molecules, and we're trying to find volume. Can we go from particles right to volume? No. We've got to go through mole town. So we got to change this to moles first. So I'm going to multiply by 1 mole over 6.02 times 10 to the 23rd. That gives me the moles. And then multiply by 22.4 liters per mole. So here it gives me the chance to use scientific notation twice. Okay, so I'm going to do this now. I'm going to show you again how to use this calculator. Okay, so I'm going to do, you can see that right there now. You can see that. 3.01 exponent 22 divided by 6.02 exponent 23. Whoops. I have to put that in parentheses when I'm doing this on the second one. I just realized that. 3.01, I'm glad I'm showing you this, exponent 22 times, now I'm going to use these parentheses, 6.02 exponent 23, close parenthesis, and hit enter. And now I get a very big number, and now I'm going to divide that by 22.4. Oh, I multiplied. I didn't divide. Sorry about that. Let's try that again. 3.01 exponent 22 divided by, now I'm going to use my parentheses, 6.02 exponent 23, close parentheses, enter. And that gives me 0.05. So I have 5/100ths of a mole. And I'm going to multiply that now times 22.4. And that gives me the final answer, 1.12. And that would be liters, because particles cancels particle, mole cancels mole, and now we're left with liter. So there you go. That's it for this video.